So we will start the class in another 2 minutes. Hello, can you hear me? Can you see the slide? Yeah. So today we'll be discussing a very interesting topic and as well as very important also. That is seepage pressure. So have you heard seepage earlier? Anyone? You can tell me. Okay, let's discuss. So seepage is nothing but passage of the water through the voids of the soil. So here, so we have already discussed about effective stress in the previous classes. Okay. See, I expect some basic answers from your side in this class. Hello. Yeah. Tell me. Seepage pressure. Yeah, seepage. I can't hear you. Yeah. Can you repeat? Can you repeat? Actually, I couldn't hear, but I could hear only last sentence. But you can repeat. Flow of water. Yeah. That's correct. That's correct. It's basically a passage of water. When it is, yeah. It just flow of water. Yeah, that is correct. So coming to the effective stress, which we have discussed in the previous classes, so it is total stress minus pore water pressure. Okay, this is total stress minus pore water pressure. Let us consider Sorry. So let us consider there is a soil here. Okay, this is soil, and above the soil we are keeping some water. So this water can flow through this soil because it is fully saturated. That is the reason why you are able to stand the water here. Otherwise it would have percolated inside, right? So now as the water is standing above the soil sample, that means soil is already fully saturated. Now if you go for a tube here, anyway, so now this height, let us say this is capital H and this height is HW, because this is the height of water which is standing above the soil. Now it is fully saturated. Let us take a point here which is A. Can someone tell me, it is fully saturated, that also I am writing here, fully saturated, having saturated unit weight gamma sat. Now can you tell me what is the total stress at A and effective stress at A and pore water pressure at A? So how do you get this effective stress at A? It is nothing but sigma A minus UA, right? So can you tell me what is total stress, someone of you? See, you have to respond fast because we don't have time. We have only 1 hour. Within that 1 hour I should finish all these things. Okay, gamma W into HW, gamma sat into capital A. Yeah, this is total stress at A. Can you tell me what is the pore water pressure? Gamma W into capital H plus small hw. Yeah, this is the pore water pressure. Now can you tell me what is effective stress? Gamma sat into, okay, yeah. So here what should I write, capital H or small h? Capital H, right? So yeah, I hope you understood the concept of effective stress. Now another question from this concept. Now if I put a tube here, definitely there will be a soil flow, sorry water flow from here because it is fully saturated and it is opened. So till where it will be filled in this tube? Can someone of you tell what is the height of the water? Okay, I don't know up to which height it will be filled, but what is the height of the water which will be filled in this tube? Water height, that is final water height in this tube. You can say H. So that means completely up to this level, right? Yeah, this is the water height which will be there in in the tube. Now Suppose, does this water flow from any, after reaching this point, after keeping the tube and after water reaching this point, will there be any flow? Will it flow down? Will it happen?
No, sir.
No. Can you tell me why? Yeah, it is same on this water surface. And one more thing, here the tube height is same as that of this height. Suppose my tube height is up to here, okay, it is above this level. Will water reach at this point? Will it reach above this point, or below, or at the same level which is there now? At the same level. See, finally, until and unless there is a equal pressure on both sides, it will travel. Once it is reaching the atmospheric pressure here and here same, then it will stop. Secondly, suppose I'll go for another tube here only, but I'll go for I'll go up to this height only. Okay, now can you tell me water will flow down, or it will flow up to here, or less than that? Water is constantly at this point. See, there is a tap, you can say. Water will not come down, always it will be at this level only, because water is coming here, and whatever extra water will flow down, okay, but the water level is always maintained constant here. Okay, you said that is correct. Even though the tube height is more, or at this, exactly at this location, the water will come up to here and it will stop. It will not flow down, or it will not go up. Whereas the tube height is less than this height, means this much gap is there. So now water is flowing here, from here. So will it flow, will it overflow, or will it stop here? It will overflow. Can you tell me why?
So because the pressure is up to a height of capital H plus small h,
Okay,
of the pressure,
yeah,
but the tube is shorter.
okay. So with which head will it flow? The head, like pressure head, there should be some head.
Capital H plus small h minus
Yes, yeah, the tube height. Let us say this is HT. So you are saying the head which is causing the flow is H plus HW minus this HT. So this is the head of the water which is actually causing the flow of this water through this sample. Suppose if it is, the tube height is up to here, okay, up to here, then it is not flowing, there will not be any flow, that is still water. So whenever there is a head, then the water will flow. Okay, now you understood the concept of, this is the basic concept which we should have before going for the seepage pressure. So this is called no seepage. Let me go to another new slide. So no seepage we will discuss first. Okay, this is no seepage. But basically there is some water and there is soil. Okay, below this there is completely soil. This is only water. Okay, now I am taking tubes at different levels. The tube height is whose height is more than the height of the sample container. Okay, now the soil is fully saturated. Now as we discussed, the water will flow from here and it will reach up to here only. Okay, then here also at the same level, here also at the same level. In this case, there is enough space for the water to reach to this height. That enough space means what? This is the space. This tube is having the space. Here also it has the enough space in this tube also. It could go up to here if it wanted, but anyway, due to the atmospheric pressure which is in equilibrium position now, so it will reach up to here, and it is at still position now. Here also it is in the still position. So now at the end, finally water, after reaching to this level, water is not flowing. Water is not flowing from anywhere to anywhere. Okay, not flowing. So when the water is not flowing through the soil, when it has reached equilibrium position, that means there is no seepage. Seepage is basically what? Passage of the water, the flow of the water which is continuously happening through the voids. Okay, that is called seepage. As it is not happening in the sample, this is no seepage. Let us take downward seepage. So let me draw there is a container here, and here I'll take I've taken little larger height. Anyway, what I'll do, let me discuss first upward seepage. Okay, upward seepage. Then I'll take soil sample here. This is the soil. Okay, this is the soil container up to here. This is the height of the soil. You can say this is capital H. Okay, and there is container height is more than the soil height, so that it can stand some water here. Okay. It can stand some water here. Let us say this is small HW. Okay, now here also what I am doing, we are maintaining constant level of the water in this container. There is this is the constant level, it will not decrease or increase. It has outlet, let us say, if it wanted. Now can you tell me, will it, the water will flow? If it flows, whether, first question is, does water flow here? Does water flow? Second question is, if it flows, direction, what is the direction of flow? Can you reply for it?
Yes, sir.
So it flows, you are saying. Okay, yes. Then what about the direction?
Downward.
From where to where? Can I get answer from somebody else? Like somebody else tried.
Upward flow.
Uh,
The flow will be upward.
Upward from. Can you take the reference of this soil position and can you tell me? Okay, I'll give you the points. Okay, this is A. Let us say. Okay, this is B, and this is C. This is D. Okay, now from.
Towards C only.
Acha, okay. So it will flow. Why? Can you tell me if this is the direction? Mm. Because
So because there is head between A and D.
acha, yes, this is the head. You are saying this is the difference in the levels of water. This is, let us say, this is HS. Okay. So because of this head, it is flowing from here to here. Here also we are giving outlet, and here also we are giving inlet. Because of this, there is a continuous process of flow of water. Suppose you are stopping the water to enter in this. So what does it then? What will happen? Can you tell me? Suppose I am closing this tap. Can someone tell me what will happen?
Like if you close this tap, water will follow the path
Yeah.
after that that will leave its course and
Yeah. What? So yeah, you are right. Here the water level in this container, which is the left side, the A point container, until and unless it reaches this D level, in this, then until that it flows. Then after that it will stop because they are coming at same level. So now as we are giving continuous inlet and continuous outlet at this height, there is always HS, head is possible. Okay, because of that head difference, the water will always flow from B to C, then C to D, then it will flow out. So this is called seepage. Now seepage is happening. So the seepage is happening from where to where? From downward to upward, from B to C. So whenever it happens, so what is the reaction in the soil? How does the soil behave? That is what we'll discuss now. So now we know the concept of the effective stresses and all. Effective stresses is not it is nothing but total stress minus pore water pressure. Whenever you want to know pore water pressure at any point, you just have to use this tube concept. Just put the tube there and take the height of the water in the tube. Okay, suppose at this point, what is the pore water pressure at this point? It is, let us say this is H1, this is H2, this is H3. At this point, what is the pore water pressure? Pore water pressure is equal to gamma W into H1 at this point, because this is the height of water. And what is the pore water pressure at this point? Pore water pressure at this point is gamma W into H2. In this tube, you can say by taking the height of the water. So whereas in this is first one and this is second one. Now what should we find out? See, this is the height of the soil. So now we can stand at this level, right? We cannot go below the soil level. So this is the ground level, let us say. This is the ground level. Only we can stand at this point, and we have to find out effective stresses at any point. Let us say effective stress at this point. Okay, at B. At B, what is the effective stress? We will calculate. So for that, what do? I'll use a tube concept and I'll put a tube at this point. Okay, a tube of height, enough height. Okay. Now when I put the tube here at this point, water will enter in this tube also with some water pressure. What is that water pressure? Can you tell me what is the water height in this tube? What is the water height in this tube? In this tube? What is the water height in this tube? Can you tell me? Anybody? Okay. Tell me.
H soil plus HW plus
Y-
HS.
HS. Yes. So always whenever used, suppose there is no soil here at this point, there is no soil here, I just used a virtual tube here. Of course the water will go up to here and it would have reached at this point, right? You just take a YouTube, not YouTube where you watch videos, the tube which is in U shape. Okay, so I am pouring water here, so of course it will reach here. Suppose until and unless they reach same height, it will travel. That's it, in same concept. If there was no soil, then it would have reached at this point. So that is what the water pressure, the level of water it can reach, the pressure inside the water at this point is it can reach at this point. Okay, after reaching at this point, will it go above this? No, it will not go above this, because the pressure at this point and at this point are same. Whereas after reaching this point, it wants to go above. As there is no space for it, it is flowing. As it is flowing, the water is coming again from here. That is nothing but seepage. Because of what? Because of this head difference. Okay, so that is how. Now you know the pore water pressure. What is the pore water pressure now at this point? At this point, the pore water pressure is the height of the water is, as somebody said, H soil plus HW plus HS. Okay, now I know the water height, that means I know the pore water pressure. Pore water pressure is nothing but gamma W. Okay, U is nothing but gamma W UB into the sum of all these terms. Okay, H soil plus HW plus HS. Now you know the pore water pressure at B. So can you tell me what is the total pressure, total stress at B, so that I can find out. If you can tell me total stress at B, I can find out effective stress at B just by deducting UB from sigma B. This is sigma B. Okay, this is nothing but total stress at B. Now can someone tell me what is the total stress? Total stress is just whatever is above the B, the pressure due to the
HW into gamma W into
gamma W into HW plus
gamma sat
gamma sat into
H soil.
H soil. See, it is nothing but whatever, whenever somebody is asking total stress, it is nothing but the stress which is coming due to the whatever it is. It may be water, it may be soil, whatever it is. You just have to take total pressure. See, I have taken the water see, gamma W into HW, gamma W into HW. At this point, whatever is water is there and soil is in saturated condition, and I multiplied with the height of the soil. So I have taken total stress which is possible. Now from there I'll try to find out sigma dash B, which is sigma B total stress minus UB. I know sigma B is nothing but gamma W into HW plus gamma sat into H soil. Okay, minus UB is what? UB is gamma W into sum of all this, gamma W into HS plus HW plus H soil. So this is the effective stress. Now gamma W HW plus gamma sat into H soil minus, now I'll multiply gamma W with every term. gamma W into H soil. Okay, now gamma W HW, gamma W HW, and now gamma sat here, this and these are common. So what I do, gamma sat minus gamma W into H soil minus gamma W into HS. So this can be written as saturated unit weight minus of the soil, of course, minus the water unit weight will give you submerged unit weight, that is nothing but gamma dash equal to submerged unit weight of soil. Okay, gamma W into H soil minus gamma W into HS. Okay, this is effective stress, right? Now a question for you, suppose this container height is not up to A, let us say it is only up to D, equal to this, up to here only. Now water is there. Can you tell me what is the effective stress at B? Effective stress at B, if container height is, or else I'll draw that.
We need to subtract H soil plus H plus
Okay, let me draw that. Okay, again there is some problem started. Okay, let me, it is nothing but so what did I say? I am taking same height. Okay, soil is here, soil height is H soil as usual, this is HW. Now water is at same level. Okay, now it is at still position because both water levels are at same level. Now if I talk about B, effective stress at B, sigma dash at B is total and UB. So how to find out UB? I'll take it tube and I'll put here. So up to where water will go? At this point, of course. Okay, so this height is nothing but H soil plus HW, and what is the total stress above B, whatever is there you have to take. What I'll do, gamma sat into H soil, this part is over, and above that there is water also, gamma W into HW, this is the total. And what is the pore water pressure? Minus, pore water pressure is nothing but this height into water unit weight, this is the pore water pressure. Now these two gets cancelled, isn't it? No, sorry, this is not just, okay, I have done some problem is there. Can I reopen again? Oh, we have lost that. We have lost that. Let me draw again. There is water, there is soil here, it's soil, there is water here too. So water flows from here to here, and this is HW. As we discussed, this is the B, and at this point if you put tube, water will go up to here. Now sigma B minus UB. So this we are talking about, this is nothing but gamma sat H soil plus gamma W into HW, whereas UB is gamma W into H soil plus gamma HW. Okay, this one. So now this is actually no seepage condition because the water level is same and then water will not flow. So this is no seepage condition basically. Okay, so gamma sat H soil plus gamma W HW minus gamma W H soil minus gamma W HW. This is HW. This gets cancelled. So gamma sat minus gamma W H soil. So it is nothing but gamma submerged H soil. So effective stress at B, it is nothing but just that you just have to take the submerged unit weight of the soil into the height of the soil. That's it. Submerged unit weight of the soil into height of the soil. Nothing to do with remaining heights. That is the effective stress at B. While calculating effective stress at any point in the soil, like let us say B, you just have to take the height of the soil sample above that B multiplied by submerged unit weight. That's it. Whereas if, as we discussed, here what is happening, upward seepage. Whenever upward seepage, what we discussed, we have derived this, we have taken UB, we calculated UB, that is the height of HS plus HW H soil, capital H soil. Then we have calculated total unit weight, total stress at B. What is the total stress? Gamma W into HW, this part, and gamma saturated into H soil, this part. Okay, then what happened? So by deducting the pore water pressure, at the end we got this. Okay, so now coming to this expression, this is upward seepage expression, and this expression, whereas no seepage expression. This is, what is the difference? You see gamma dash H soil, whereas gamma dash H soil minus H gamma W into HS, where HS is the head difference. This is the head difference, that is called seepage head, due to which seepage is happening. If HS equal to 0, these two levels would have been equal, then there would have been no flow. So that means whenever seepage is there, let us say, what you have to do, the effective stress will become submerged into height, okay, height of the soil, in submerged unit weight into height of the soil minus And remember, this is upward seepage. Upward seepage only I am talking about. Minus gamma W into the head which is causing the flow. The head which is causing the flow. This is the effective stress at any point. At any point of at the rate h. Okay, at the rate h, that h soil. That means effective stress is getting reduced. We don't want effective stress to reduce, instead we want effective stress to increase for the soil to be on safer side always. Remember that. You want soil to be on safer side, you have to have some effective stress. Effective stress should not become zero. So what happens when effective stress becomes zero? Let us take, so there is a water, okay, there is soil here. Already due to this water presence, soil is already in the saturated position. So if you keep on adding water, what will happen? This soil particle will try to flow. Okay, when the soil particles are trying to flow, that means the soil particles are divided. They are going away from each other. When they are going away from each other, at one point they will of course they lose contact from each other. Then you can't give any load onto the soil when they are not in contact. When they are not in contact, if you are unable to give the load, what will happen? If you put any load, suppose you are putting your leg, you will just punch inside. That is the reason that because there is no effective stress. Effective stress is the stress is nothing but intergranular pressure or stress. Is the pressure or stress which is transferring from one particle to another particle. That is called effective stress. If effective stress is possible, then only you can apply some load on this soil. Okay. If there is no contact, that means effective stress is zero. Effective stress is what? Intergranular pressure. If there is no contact, then intergranular pressure is zero. If it is zero, that means they are away from each other. If they are away from each other, if you put your leg, you will just punch. It cannot take any load. If you try to build any building, it will just go inside. It will just punch. There will be punching failure. Okay, I'll talk about the different kinds of failure in the soil in the next class anyway. So that kind of things happen. So effective stress, our aim, it should not become zero. Whenever it becomes zero, that will happen. That is nothing but liquefaction. Okay, liquefaction will happen. So anyway, now when the seepage is there in upward direction, what will happen? Effective stress is reduced by this much amount when there is no seepage. Okay, when there is no seepage, effective stress is just nothing but submerged weight into height of the soil. Okay, that's it. If there is no seepage, this one. If there is seepage, it is reduced by this much amount, seepage head times unit weight of the water. Now we will discuss about the downward seepage. How does it matter? Okay. Downward seepage. So in downward seepage, when can it happen? What I'll take a container of soil, I'll put water here, and there is a soil here. Then I'll put this soil in another container, okay, where there is a water again, okay, and whose container height is this much only. Now this is the level of water here. Now can you tell me, suppose this is A, this is B, this is C, okay, this is C, yeah. Now can you tell me what is the direction of the seepage? First of all, does seepage happen? Can you tell me, does seepage happen? Does seepage happen?
Yes, sir.
From where to where?
So from A to B to C.
From A to B to C, because see, the level of water is here, it is going this direction. So water is coming here. If water cannot flow from here to here, it can flow from here to here, because this height is at higher position. A is at higher position. Let us say this is D. D is at D is below compared to A. That water should definitely flow from height to higher position to lower position. So water will flow like this only. That means like this. Whereas in the previous diagram where we are talking about here, so water was flowing from down to up. Sorry, not here. Sorry. Water was flowing from B to C, from down to up, because water level is higher position here. So it will travel like this, then it will go like this. Whereas at this point water is moving directly downward in the soil sample itself. This is soil, let us say this is soil. So soil height, let us take this is soil height is again H soil from B to C, and this is HW, okay, this water. Then what do we do? Let us take this as HS, because this is the level difference from A to D, because of which the water will flow. Okay, now if I put a tube here, a tube I will put here. What, up to where it will go? Water in this tube. Can you guess where up to where the water will reach? In this tube, can someone tell me? Suppose tube is, of course I forgot to draw, tube height is, sorry, tube height is like this. Can you tell me what is the water height in this tube? See, the container is opened here, means whenever water is flowing from here to here, it will flow down. It can't go beyond, because container height is up to here only, up to D. This is the D point. Okay, this one. And I am putting a tube at the bottom of the soil, at C, at this point. So water will enter anyway. When the water is flowing through the soil, it will enter in the tube as well as it will enter into the container, both. So whenever it is entering into the container, it will go down after reaching D, because container height is only up to D. So where up to where the water will reach in this tube? It will,
Soil plus HW
H soil plus minus HS. So that means it will reach only up to D, you are saying, basically. Why? Because see, the end of the water is having two outlets. One outlet is this container, big container, okay, whose height is up to D, and one outlet is tube. So both outlets will have same level. It will not go beyond up to here. It will not reach here, because there is another outlet which is working up to D only. So finally this and this level will be equal at the end. So that is the reason why water height will be up to here. So this is the only water height which will be there in the tube. So this height, how to calculate? I know this height, that is H soil. I know this height HW. I know this height also, this D height, that is HS. So what is this height? It is nothing but H soil plus HW minus HS. This is the height, this height. So that is the pore water pressure at D. What is the pore water pressure? Pore water pressure is the height of the pore water multiplied by gamma W. What is that height of the pore water in the tube? That is only this. You should not confuse whenever this diagram is given. Suppose this tube is not given. Let us say this tube is not given, but only this container is given and this height is given. If somebody asks what is the effective stress at C, effective stress at C, total stress at C minus pore water pressure at C. What is the total stress at C? It is nothing but gamma sat into H soil, right? Gamma sat into H soil plus gamma W into HW, gamma W into HW. This is the total stress at C. But what is the pore water pressure at C? People may think that pore water pressure is equal to the height of the water from here to here. That means H soil plus HW into gamma W. You may think that H soil plus HW. That is not the thing. You should remember what is the outlet height. Outlet height is only CD. Suppose this is C and CD is the only height. That height is here. What is that height? H soil plus HW minus HS. See here, HW and this will get cancelled. Now gamma sat into H soil, gamma W into H soil. So I can write gamma H soil minus, sorry, I can write this as gamma sat minus gamma W into H soil, and this gets cancelled and extra minus into minus plus gamma W into HS. Okay, so in the next slide if I go, then it is gamma submerged into H soil plus gamma W into HS. This is gamma dash into H soil plus gamma W into HS. So what happened to the effective stress? Effective stress is increased by this much head. Why? The water is flowing from the top to bottom. The water is flowing from the top to bottom. Whenever seepage is happening downward, then effective stress increases. Then soil behaves stiffer soil compared to the no seepage condition. So we want downward seepage to happen. Downward seepage is fine for us, whereas upward seepage is not fine for us. No seepage is also fine. It is little fine, but compared to that, downward seepage is far better because it is increasing the effective stress by the seepage head. Seepage head is HS. That much head is causing extra effective stress. Now, so we will talk about the critical condition. Critical condition means what? Critical condition. What is the critical condition? Whenever effective stress is 0, that is a critical condition. So when can effective stress becomes 0? So this is finally downward seepage formula. It is nothing but you just have to remember that there is always this term exists. Okay, this term submerged unit weight into height of the soil, whether it is getting added or subtracted or nothing. Nothing means no seepage, added means downward seepage. If it is minus, that is upward seepage. So finally effective stress can be written as gamma submerged into H soil plus or minus gamma W into HS for the seepage condition. If it is downward, it will be plus. If it is down, if it is upward, if it is minus. If it is no seepage, this term itself becomes 0. Only this term will exist. Only this term will exist. Now, when does effective stress becomes 0? Only when this condition is existing. Only in upward seepage critical condition can happen, because in downward seepage there is plus, it cannot become 0 because something is there. There are two addition is done between two terms. Subtraction, if subtraction is happening, then we can expect the subtraction might become 0, but if there is addition, it cannot become 0. That's why in critical condition may happen in the no seepage condition. So no seepage, upward seepage condition. Upward seepage condition is formula is this. So let us equate this to 0 and let's see when does that seepage happen. Okay, so critical condition, I'll do this gamma dash h, let us take h only for the time being, gamma w seepage head equal to 0. Now gamma dash equal to gamma w into hs. Okay, then this, of course, now what can be done, this hs by h, then gamma dash by gamma w. Gamma dash, what can we write, gamma sat minus gamma w, right? Then gamma w, then gamma sat by gamma w minus 1. So this is hs by h soil. Okay, see, head divided by the length of water to travel along the soil, that is h soil. This is nothing but hydraulic gradient. You might have heard in fluid mechanics also, hydraulic gradient. So the head which is causing the flow, that is seepage head hs, through along which length it is traveling, so that is called hydraulic gradient. This is the hydraulic gradient that we can say I. So now I can be written as gamma sat by gamma w minus 1. Okay, and this is of course critical hydraulic gradient, because I made it critical condition. From the critical condition I derived this. That is the reason why it is critical hydraulic gradient, which is denoted by IC. Now if we again so what is the hydraulic, there is some problem here, just don't mind. So what is the hydraulic, critical hydraulic gradient? Now gamma sat by gamma w minus, it is gamma sat, gamma w minus 1, gamma sat let me reopen that, it is giving a lot of confusion. Now I hope you can see, right? Right?
Yes, sir.
Yeah, now see, HC is this, we have derived now, sorry, IC. Now in the next slide I have written the same formula. So you know the formula of gamma sat in your first lectures only, G plus ESR gamma W 1 plus E is the formula, okay, for gamma sat. Here SR equal to 100%, that means 1, okay, then it is G plus E by 1 plus E gamma W. So you just substitute this in place of gamma sat, G plus E by 1 plus E into gamma W divided by gamma W minus 1, this gets cancelled, G plus E minus 1 plus E by 1 plus E. So finally G minus 1 by 1 plus E. This is the critical hydraulic gradient for a soil. You have to, this is critical hydraulic gradient, okay. This is the derivation, G minus 1 by 1 plus E. So now we will solve a question regarding that, okay. In the GATE 2011 paper, question number 10 of 1 mark. So here it is given that for a saturated sand deposit, the void ratio, that is E, and specific gravity, that is G, are 0.7 and 2.67. So E is 0.7, G is 2.67. So what you have to find out? Hydraulic gradient, whose formula is G minus 1 by 1 plus E. Just now we derived. So just find out this and tell me the answer. Find out this. So I'll close the session in 2 minutes.
0.9.
Yes, so the option B is the correct answer. Okay, is there any doubt? So you can go through the lecture again. I am uploading the live sessions. I am recording them and I am uploading. You can see that, right? You are getting the live sessions. So I hope there is no doubt. Shall we close the session? Sir, during lockdown, college not work properly. So as per syllabus, no software taught us. So I am little unaware what type of software have in BTech. Sir, if you guide whole thing, it will really good for me. In future, I will complete another platform. Can I personally contact you as your time? It will help me. Manabendra, in the next class, we will discuss about this. Okay, about your configuration and all. Okay. So, anything else? Yeah, okay then. So I'll leave the meeting. So see you guys in the next class. Bye.